Got it started?
Yeah, it's started now.
Okay, and now you can turn it around. Now it's going. That's it, and then you can pop it in the thing.
It's like really foggy.
Hello, third classmates.
Oh.
You're all currently jigging, so let's feel
Now, Preston, can we see the green all right?
It's like really foggy.
Hit the thing in the middle. Just hit as if you're going to...
Ah, there we
Is
go.
that done better now?
Perfecto.
Okay. All right, normal distribution. Okay, so we did talk quickly. Those people that were here, tell me about the normal distribution. What is the properties of a normal distribution? Symmetrical. Good. And it's symmetrical about what? Mean. So if I was to cut this directly in half, that position would be the x bar, it would be the mean, but what else would be at exactly that point?
The median.
The median, so the score that's exactly in the middle, and the score that occurs the most, because remember this is a frequency, yes? So all we've done is we've created a curve. We've just drawn a curve over the top of what would have been a frequency histogram. Okay? So we've had the histogram, and then we've drawn the O-guide. Remember we call that an O-guide? It's the polygon that goes over the top. So essentially this is a histogram. So what this is here, even though we don't show this axis, it's the frequency. Alright? So the score here, this is the score that occurs the most, because it's the highest score. Obviously it's the highest histogram. Okay? Box. We all alright with that? So that's the mode. It's also the mean, because it's symmetrical, it will also be the median, the score that's exactly in the middle. Okay? Questions? So underneath that, underneath the entire thing, if I was to shade it all the way out, is 100% of the data. Are we all happy with that? Essentially, that's all the little histogram boxes, and I've just drawn a line over the top. So every single one of my scores is represented in that polygon.
Okay.
Happy with that? Yeah? I've got my data, and I've drawn a frequency histogram, and then I've drawn a polygon over the top. So obviously that's where all of my data lies. It's all underneath that curve. Now this data just happens to be symmetrical. So that means that it follows a normal distribution. So it's distributed or spread evenly. Okay, and symmetrically. There are things in life that do make this pattern or make approximately this pattern. Okay? So that's nothing new. That just means that there's my data and I've plotted it. I've graphed it. When it follows a normal distribution, and only when it follows a normal distribution, so only when it's symmetrical and when the mean, the mode and the median are at exactly that point that's exactly in the middle of my data, do we know that if this is the mean, if we went up, if we added one standard deviation, what's the standard deviation again? It's the spread of the data. Okay, it's how far it deviates away from the mean. So if you had data like that, it has a bigger spread than if you had a normal distribution that looked like that. Why? Because it's closer to the mean. So there isn't as much deviation away from the mean. It's all very close. Okay, that's my mean down the centre there. That has a smaller standard deviation than something like this. Do we agree? So standard deviation tells me it's a standard gap that tells me how far my data has been spread away from the mean. So if it is symmetrical, if it follows a normal distribution, then within one standard deviation of my mean, and I'll show you all three first. So this is adding 1, adding 2, taking a way of going down by 1 and going down by 2. Okay, we happy with that? What do you notice? I've got more of the data in that group now, correct? So I've gone up by one of those gaps and down by one of those gaps, and I got that much of my data included. Okay? I went up by 2 of those gaps and down by 2 of those gaps. Remember, they're the same size. Now, if I was to go down and up by 3 of those gaps, I would pretty much encompass just about all of my data. Do you agree? Have I drawn them around about the same scale? Can you see that if I've just drawn, they're about the same size diagrams, okay, and the gaps are about the same size? So if that's, I'm just going to draw down the centre just so you get an idea. So in 3 standard deviations, I pretty much get almost all of my data. That's what it looks like, doesn't it? The exact numbers, and these work only because it follows a normal distribution, only because it is symmetrical, and only because the mean, the mode, and the median are all at that one point that is directly halfway between my data. Okay? If that is the case, then 68% of my data lies within 1 standard deviation above and 1 standard deviation below, or in other words, 1 standard deviation from my mean. A deviation up and a deviation down. 95% of my data is within 2 standard deviations. So I've just about got the lot. So you've got probably 2.5% there and 2.5% there. Everyone okay with that? But if I go 3 standard deviations, I get 99.7% of my data lying within 3 standard deviations of the mean. So that means that out here I don't have very much. How much have I got outside of those 3 standard deviations? Yeah, 0.3 altogether. So on this side I've got, sitting out here, is 0.15%. Everyone okay with that? And sitting outside here, I've got 0.15%. Now that's not 0.15 scores, that's 0.15%, which is 0.15 out of 100, which is very small, correct? Alright, these numbers only work because it is a normal distribution. Alright? And there are a range of questions that will ask you about finding what percentage sits where. Okay? So you need to think about, well, that's going to be 32% outside. So it'll be 17.5, is it? 16.5, whatever it is. Okay? 16 either side. Okay? So you can now work on exercise 10.1, which is just some basic questions on just calculating percentages that sit outside of that. Alright? And the next thing we're going to talk about is Z-scores, and all we're going to do is just, instead of referring it as standard deviations, we're just going to call it a Z-score, which means that we just say it's 1Z, it's Z, Z, 2Z, 3Z. So instead of doing the X bar plus 3 standard deviations, we're just going to write it as a Z. Okay, it just simplifies it for us. But for now, I just want you to do 10.1, and you can just work on doing some of the questions. Can you stop that, please, Preston?
Yeah.